Welcome. Next, we will do an example using the implicit function theorem where we are going to do a partial derivative. The equation is ln of z plus 9z equals xy. This problem is from our textbook. It's a very simple problem which can be done by the old method, but the new method is never more difficult than the old method. So we'll just continue using our new method. So the first step is to bring all the terms to the left. So I need to subtract xy from both sides. And then I'm going to call the left-hand side of the new equation my function f. That's what I have done here. So I get ln z plus 9z minus xy. Then to find dz over dx, I find df over dx and df over dz first. And when I do this, I pretend that x, y, and z are all independent variables. So when I do df over dz, pretend that x is a constant. And when I do df over dx, I pretend that z is a constant. In any case, since we're doing partial derivatives, we pretend that y is a constant. So let's first explain how I get this for df over dx. In the first term, there is only z. Since I'm pretending that x, y, and z are independent, it's like a constant. So is 9z. So these are both constant terms, so the derivative is 0. The last term I have minus x times y. Since y is like a constant, it's like a constant factor. So the derivative is negative. Derivative of x with respect to x times y, that's negative 1 times y or negative 1. When I do df over dz, well, in the first term I have only z, so I get the derivative with respect to z, which is 1 over z. In the second term I have plus 9z, the derivative with respect to z is 9. In the last term minus xy, I have only x and y, and I pretend they are constants when I'm doing this partial derivative. So the last term is like a constant term, its derivative is 0. So it's easy to compare this with the answer in the book. I'm going to rewrite this as a single fraction by putting them over a common denominator. The common denominator is z. The second term is 9z over z. Put the two fractions over a common denominator and add 1 plus 9z over z. dz over dx is the negative of df over dx divided by df over dz. But this should end up in the denominator of the denominator, this in the denominator of the numerator. And then you also have a negative in front. And I'm going to plug this in for df over dx, this for df over dz, and that gives me the partial derivative. Of course, I can simplify this. I can combine the two negatives. Dividing by 1 plus 9z over z is same as multiplying by z over 1 plus 9z. So this z will end up in the numerator. So if you do all the algebra simplification, you get yz over 1 plus 9z.